Good morning to all. Myself Prabhake, working as Assistant Professor in Electronics and Communication Engineering Department, Sai Vidya Institute of Technology, Bangalore. Today we'll discuss about functional units of computer system, which is one of the major topic in Module 1 of Computer Organization and Architecture subject. Functional unit of computer system is broadly classified into 5 units. First one, input unit, memory unit, arithmetic and logic unit, output unit, and control unit. This block diagram gives you a pictorial representation of functional units of computer system. You can make out here an input module, output module. Together we will call it as IO module. Memory unit, arithmetic and logic unit, control unit. Arithmetic and logic unit and control unit. Together we call it as processor. Computer system mainly consists of 5 functional independent main parts, that is input unit, memory unit, arithmetic and logic unit, output unit and control unit. The input unit accepts code information from human operators using the devices such as keyboards or any other computers over a digital communication lines. The information received is stored in the computer memory either for later use or to be processed immediately by the arithmetic and logic unit. The processing steps are specified by a program that is also stored in the memory. Finally, the results are sent back to the outside world through the output unit. All of these actions are coordinated by the unit called as control unit. The arithmetic and logic circuits in conjunction with the main control circuitry is referred as processor. Input and output equipment oftenly collectively referred as input-output unit. In short, we call it as IO unit. Input unit. Computer accepts coded information through input units. In computing, an input device is a piece of equipment used to provide data and control signals to an information processing system, that is your processor, such as a computer or any information appliance. Examples of input devices are keyboards, mouse, scanners, digital cameras, joysticks, and microphones. The received data from the input device is either processed by the CPU or stored in the memory for later use. Memory unit. Computer memory is a physical device which is capable of storing information either temporarily or permanently. The main function of the memory unit is to store, program as well as data. Two classes of storage elements are available. They are primary memory and secondary memory. Primary memory. It is a fast memory that operates at electronic speed, and it includes ROM and RAM and located very close to the CPU on the computer motherboard, enabling the CPU to read data from primary memory very quickly indeed. It is used to store data that the CPU needs immediately so that it does not have to wait for it to be delivered from the other memories. Secondary memory, it is usually physically located within a separate storage device such as hard disk drive or solid state drive, which is connected to the computer system either directly or over a network. The cost per gigabyte of secondary memory is much lower, but the read and write speeds are significantly slower. This diagram gives you an classification of computer memory. Computer memory is basically classified into primary memory and secondary memory. Primary memory once again classified into RAM, ROM. RAM is random access memory, ROM read-only memories. RAM is once again divided into two categories, static RAMs and dynamic RAMs. And different types of ROMs are available like PROM, EPROM, EEPROM. Coming to the secondary memory is categorized into different types: hard disk drive, solid state drive, compact disk, floppy disk, magnet tap. The computer memory system consists of large number of semiconductor storage cells which are capable of storing one bit of information. They are handled in groups of fixed size that we call it as words. One word can be stored or retrieved in one basic operation. The number of bits in each word is referred as word length of the computer, and typically it will be 16, 32 or 64 bits. To provide an easy access to any word in the memory, a distinct address is associated with each word location. Addresses are consecutive numbers starting from 0 that identify successive locations in the memory. A particular word is accessed by specifying its address and issuing a control command to the memory that starts the storage or retrieval process. This diagram gives you an example of a memory location of different word length. If I say a memory location which is always be treated as one location is 8 bit, under that condition the word length will be 8 bits. If the processor is 16 bit processor, then the word length is 16 bit. It is capable of accessing two locations at a time. A processor of 32-bit word length is capable of accessing 4 memory locations at a time. Similarly, a processor of 64-bit word length is capable of accessing 8 locations at a time. Memory in which any location can be accessed in a short and fixed amount of time after specifying its address, we call it as random access memory. The time required to access one word is called as memory access time. It typically ranges from few nanoseconds to about 100 nanoseconds for modern RAM units. The memory is normally implemented as a memory hierarchy for 3 or 4 levels of RAM units with different speeds and sizes. The small, fast RAM units are called as cache memories, which are tightly coupled with the processor contained on the same chip to achieve high performance. Largest and slowest unit of memories are referred as main memories. Although the primary memory is essential. It tends to be expensive and does not retain information when power is turned off. That's why the secondary storage comes into the picture, which can store large amount of data and many programs, particularly for information that is needed infrequently or which is accessed infrequently are stored on this secondary memory. Access times for secondary storage are longer than the time needed for the primary memory. The examples of secondary storage devices are magnetic disk, optical disk, and flash memory devices. Coming to the arithmetic and logic unit. Most computer operations are executed in the ALU of the processor. ALU is a short form for the arithmetic and logic unit. Any arithmetic or logic operations like addition, subtraction, multiplication, division, comparison of numbers are initiated by bringing the required operands into the processor where the operation is performed by the ALU. For example, if two numbers which are located in the memory are need to be added, they are brought to the processor and addition is carried out by the ALU. The sum may be stored in the memory or it can be retained in the processor for immediate use. When operands are brought into the processor, they are stored in a high-speed storage elements. We call it as registers. Each register can store one word of data. Access time to register are even shorter than access time to the cache unit on the processor chip. Output unit. It sends processor result to the outside world. Main example of output unit can be a monitor or a printer. Coming to the printer, most printers employ either photocopying techniques as in laser printers or inkjet streams. Such a printers may generate output at a speed of 20 or more pages per minute. Some units such as a graphic displays provide both an output function showing the text and graphics and input function through touchscreen capability. The dual role of such a unit is the reason for using single name as I/O unit in many cases. Coming to the very important unit of the computer system, that is a control unit. The memory, arithmetic and logic unit, and the I/O unit stores and processes the information and perform input and output operations. The control unit coordinates the operation of different units in the computer system. The control unit is effectively the nerve center that sends control signals to other units and senses their states. I/O transform consisting of input and output operations are controlled by instructions of I/O programs. Control circuits are responsible for generating the timing signals that govern the transfer and determine when a given action is to take place. Data transfer between the processor and the memory are also managed by the control unit through timing signals. Much of the control circuitry is physically distributed throughout the computer system. A large set of control lines, which are also called as control wires, carries the signals used for timing and synchronization of events in all units. Coming to the summary of the functional units of the computer system. The operation of computer can be summarized as follows. The computer accepts information in the form of programs and data through an input unit and stores this information in the memory. Information stored in the memory is fetched under program control into an arithmetic and logic unit where it is processed. Processed information leaves the computer through an output unit. All activities in the computer are directed by the control unit.